Alright, everybody. A little higher order derivative practice today. Find the first, second derivative. This is out of Stewart 3.8 Gibbons that you don't have answers to. And again, we'll start with number 6, which is f of t equals t to the 8th minus 7t to the 6th plus 2t to the 4th. And again, pause it if you want to do it yourself, but I'll do it pretty quickly because these are a simple power rule problem. The big problem will be here is if I screw up the multiplication. All right, so there's the first derivative. Now I literally just have to take the derivative of that. I'll do that in blue. 7 times 8, 56. Reduce the power by 1, 6. 5 times 42. 5 times 40 is 200 plus another 10, 210. T to the 4th. And the last term is 24t squared. And we just found the first and second derivative of that function. Working on, we'll do number 8, which is theta times sine theta. This one's a little more complicated. Because you've got to realize immediately the first derivative is going to have 2 terms. Because we're taking derivative with respect to theta. So I got f on the first, and I got sine theta as a second. So derivative of theta is 1. So sine theta plus, and then derivative of theta, and the derivative of sine is cosine theta. So there's the first derivative. All right. The second derivative, I'll change colors. I can see the derivative of sine is cosine, and then I'm only going to get a product rule again. All right, so I got to work through this. All right, so the derivative of sine is cosine. Then I got a chain rule. Derivative of theta is 1, so I got another cosine. So I'm going to have some like terms. And then derivative of that is negative of cosine is negative sine. Thank goodness there was nothing in the argument. Everybody, we should be clear that this for sure would require simplification because it's just too easy not to do it. And there's the second derivative of y equals theta times sine theta. Let's do a couple more. We'll erase these. Here, I'll go entire page for a second so we can erase easy, and we'll try to pick off 10. 10 is the quotient rule. All right? So if we look at 10, I can tell it's a rational expression. It's 2x plus 1 over x minus 1, g of x. So I want to find the first and second. I don't think the first is that hard, but the second is going to be, you're going to have to take some care. So g of x is 2x plus 1 over x plus 1. I will use the quotient rule. That you could bring up x plus 1 and try to put powers on stuff, and it would work as a product rule, but it'd be a little ugly. All right, so let's see, g prime. Derivative of the top, derivative of 2x plus 1 is just 2 times the bottom, minus derivative of the bottom, which is just 1 times the top, all over x plus 1 squared. And this is where you have to simplify. You don't have a choice. Now you got to do this. And some tricks of the trade, if you're willing to take some chances, I can do this. And I can see the numerator becomes 1 over. So now you know it's a book problem. Now you know it's a book problem. It becomes this for the first derivative. Now, everyone, don't overthink this. Do the quotient rule again. Your temptation to square out the bottom is a bad idea. Derivative of 1, the top is 0 times the bottom, and I'll write the bottom so we see it. Minus 1 times derivative of the bottom. Now we do a chain rule, right? We do a chain rule of that. Right there, okay? And I bring down the 2, change the power to 1, because 2 minus 1, and then the derivative of the inside is 1. I want to make sure you think that you took the derivative of the inside. All over x plus 1 squared, so it's to the 4th. And my second derivative of this problem then becomes, this is 0. I get negative 2 times x plus 1 over x plus 1 to the 4th. Well, guess what? I can cross off that and get this to be a cube. And my answer is negative 2 over x plus 1 to the 3rd. And everyone, this is what I would try to do if I was making a test. I would try to make sure it worked out and simplified. All right. Again, this was number 10. All right. First and second derivative. All right. tell you what, 12 seems like a disaster, but it's much easier than the one we just did. I kind of, let's see, maybe I can get everything onto one video here. 12, I'm going to rewrite it rational exponents as we go. It's a h of s. I hate s, but we'll keep it s to the half plus b s to the negative half. And I'll keep the s in parentheses so I see them that way. I don't have to worry about the chain rule. We don't have to do the a is a constant, so we just go h prime of s, bring down the half. So how about half a s to the negative half plus, not plus because the negative comes down, negative times the b is negative half b s to the negative 3/2. All right, and you know what? I'm not even gonna really overthink this. I'm not going to bother right now simplifying that. I assume you can do the radicals if you had to. Negative times a negative, positive is negative 4th. A s to the negative 3/2. Negative times a negative is positive 3/4. B s to the negative 5/2. Keep practicing, guys. The next two are kind of the same. All right. We'll talk to you later.